In this video, we will be discussing parasitic loads in an RV and how to deal with them. What is a parasitic load anyway? Most people think of a parasitic load as unwanted current flow when a particular device is turned off. However, what is called a parasitic load in a typical RV is actually normal. Many electronic devices these days are still powered on when turned off. A good example is the stereo in your RV. Most automotive stereo equipment has two power leads. One lead goes to a power switch or ignition switch and actually turns the stereo on and off. However, a second lead goes to the battery, or at least is not switched, and keeps the standby circuits energized in the stereo. This keeps the memory circuit powered. The result is the stereo system consumes a small amount of power even when it's turned off. So this is in reality more of a standby load than a parasitic load. Other devices in your RV that can require standby loads include furnace, refrigerator and hot water circuit boards, 12-volt USB power ports, motion detecting lights, propane detectors, and any user-installed items such as dimmer switches and so on. While each of these items do not consume a significant amount of power, they do add up if you have many of these devices. And that can affect your off-grid time if you boondock or dry camp, in other words, camp where there is no electrical power available. A good rule of thumb is each residual load is approximately around 20 milliamps. The typical LED found inside electronic equipment will take between 10 to 20 milliamps to operate, so that's pretty close. When expressed in battery discharge, this would be 20 milliamp hours. If we consider the typical lead-acid battery having 100 amp hours, the 50% discharge point being 50 amp hours, it would take 104 days for a 20 milliamp load to discharge the battery. This is no more significant than the self-discharge rate of the battery, so it can be ignored. However, we certainly will have more than one standby load. We will likely have many more, and they add up. For example, let's consider 10 standby loads of 20 milliamps each, or in battery terms, 200 milliamp hours. Now our 50% discharge point is 10 days. This can be a significant issue if we are boondocking, especially since we probably will have more than 10 standby loads. Therefore, the goals of this video are to, number one, identify the standby loads, and number two, minimize those loads, especially when boondocking. First, you will need to know how your RV's DC system is wired. Shown here is a typical RV setup. While this is common, your RV may or may not be wired this way, so you will have to verify how it is connected. In this setup, the slide-out and leveler systems are directly connected to the battery via dedicated breakers. Also, a fuse panel, which is the main DC distribution point, is typically connected to the battery, often with a battery switch. The breakers for the directly connected devices are typically located at the battery, however they may be hidden behind a panel, such as you see here in my RV. The fuse panel is located in or adjacent to the AC breaker distribution panel. Quite often, a combo AC-DC panel will be used. If your RV has a battery disconnect switch, it could be located virtually anywhere in your RV, so you may have to search to find it. I would look in the storage areas first. Now that you know how your RV's DC system is configured, we need to measure the standby currents for each individual circuit. There are two different ways to do this. You can measure the voltage across the fuse for that circuit, or you can measure the current going through the fuse. The method you use is dependent on your skill level and the equipment that you have on hand. The easiest method is the voltage, or what I like to call the by reference method. In electrical circuits, components are generally wired in series, including the battery, fuse, wiring, and load. Therefore, there will be a small voltage drop across the fuse, which is proportional to the current flowing through the fuse. The theory is that by measuring the voltage across the fuse, we can somewhat determine the current passing through the fuse. There are charts available online that provide a cross-reference between fuse voltage and current, and I will put a link to one such chart in the description below. Also, there are different charts for ATO-ATC, Mini, Maxi, and other fuses. The most common fuse in an RV fuse panel is the ATO-ATC, so that is probably the chart you want. You will be measuring voltages in the millivolt or even microvolt range, so you'll need a fairly accurate multimeter. But how accurate is this method? Contrary to internet myth, not very accurate, as I will demonstrate here. To perform this test, I'll be using my Signet bench power supply to provide 13.6 volts. And I will be using my iTech DC electronic load, and I'm setting it for constant current mode, which will rule out any differences in circuit length. I've set it up for 200 milliamperes and turn the load on to get it exactly 200 milliamps. And I'm going to use my Rigol Precision Bench multimeter, which is far more accurate, and we'll use that to measure the voltage across the fuse. And I'm replicating the fuse panel in the RV with this mini fuse panel. And all I have to do now is measure across the fuse. And to do that, most ATC fuses have the leads actually coming out the top. So all we have to do is connect our voltmeter to the leads, and then we can measure the voltage. When we measure the fuse voltage, we're measuring 3.1 millivolts, or say 3.2 millivolts. Looking at the fuse chart for ATC and ATO fuses, the values in the left column are in millivolts, and the values in all the columns to the right are milliamps. So the left column is the voltage you read across the fuse, and the right column is the amount of current that should be going through that fuse. The 2 amp fuse values are in the third column. Remember, we measured 3.18 millivolts, so we will use the 3.2 millivolt row. It shows that the current through the fuse should be 60 milliamps. But remember, we loaded the circuit with our electronic load for 200 milliamps, so this is not accurate at all. Further, in actual use, the measured fuse voltage could even be more inaccurate, depending on the wire gauge and the length of the circuit between the fuse and the load. The only good thing about this test is that it does show some voltage drop, however inaccurate it may be. This might be sufficient for a go, no-go test when looking for standby currents, so if you have no other method at your disposal, you'll at least be able to obtain some result. Next, let's look at methods on measuring the current through the fuse. Directly measuring the current in the circuit generally requires removing the fuse and then putting the meter leads directly across the fuse holder. Well, you see it's difficult to do that with these slots. However, in this case, I can go between the supply voltage and the output, and you see I measure 198, 199 milliamperes, which is what the power supply is putting out. And I have the meter, as you can see, in the amp scale, and I've had to move the test lead from the volt lead to the ampere lead. Now, most meters are generally designed for 10 amp loads or less, so we can get into trouble if we have more than 10 amps of current flow. However, when we're looking at standby loads, we're usually way under that. Even though this does work, it is somewhat difficult because we cannot look at the terminals in the fuse here. Now, some distribution panels you can because these are exposed, but I'm just showing you one that is not, and you may run across this style. So how do we take care of that? Well, there's a product from a company called Electronic Specialties, and it is Fuse Buddy digital multimeter adapter. And it's not very expensive, but what it does, it gives you a fuse adapter for, in this particular case, ATO-ATC, and then the set of test leads that go directly into the meter. We also have a place for the fuse. So we don't lose fuse protection when we use this. We're set at 2 amps here. Remember, this is 10 amps. So replacing the leads in our meter. Now we can plug this in. There we go. And then we can rapidly go from circuit to circuit by plugging this adapter in to each slot. So that's a pretty good option, very low cost. And I'll put links on the description and on my website where I got these products. And if you want to go a little further, FuseBuddy makes a test kit that has its own monitor and different adapters. And this kit is about $60, so not everybody's going to want to go out and buy it. We bought it because here at RV Project we aim to please. And this test set includes a meter as well as different adapters. And we still have the same ATO-ATC adapter here. It's an ATM or miniature adapter and a battery terminal adapter. These have the same ends, so you can use these adapters with either a meter or with a monitor that they send you. And if we look at the tester, and this is a 100 milliamp resolution, it does show 200 milliamperes. And there's also a little graph on here, which is kind of nice. And so this actually works pretty good other than maybe the resolution. So that's the only real downfall of this. And this is also 0 to 30 amps. But if you don't want to spend that much money, you can buy the adapter standalone. And this is around $20. And the same thing, you just put a fuse in here, plug it into the circuit. Interesting, this is a minus sign. And if you turn it around, the minus goes away. You can see that it measures 100 milliamperes, which is really not all that accurate. This is a 0 to 30 amp tester with a resolution of 100 milliamperes. So the use of this is a little bit limited. And this is a 304B, and this is a 20 amp circuit tester rather than a 30 amp. And this has a resolution of 10 milliamperes. So 0 to 30 amps with a 100 milliamp resolution, or 0 to 20 amps with a 10 milliamp resolution. For our purposes, this is going to be better. And so with the 304B, we'll plug this in. We show 190 milliamps. And again, this is around $20 or so for this one. And for the purposes of standby currents, the 304B is going to be outperforming the 306B. Of course, a multimeter is going to outperform both of them. Now, one issue with the fuse buddies is the manual used to say to not test more than 10 seconds. I was a little bit curious about that. And the reply from the manufacturer was, the 10 seconds is a standard which was established by some famous digital multimeters like Fluke for reliability reasons. If you take a look at any digital multimeter with a 10 amp range, most of them will say no longer than 10 seconds. And Fuse Buddy has an ampere shunt inside of it, which will heat up the longer the high current is passed through it. These products are designed and tested to handle much longer time frames. For example, we quit testing at 30 minutes. But the liability keeps the official advised time frame at 10 seconds due to established industry standards. It's interesting that there is no longer a 10-second limitation that I can read on here since I asked that question. When we're looking at standby loads in the 1 amp range or less, you're not going to have an issue, I don't think. Anyway, here are the options that you have. We may also need to measure for standby current at the battery, especially if we have circuits directly connected to the battery. This will require disconnecting the battery as shown. We can disconnect from the negative or positive terminal. However, often the negative terminal is preferred as there is typically less wiring on that side of the battery. It's usually just one big connection to ground. And now that we know how to test for standby current, we can begin testing. Turn every 12-volt DC powered load off in the RV, at least the normal switched loads like lights, radio, antenna amplifiers, and so on. Then go to the fuse panel and test each circuit. This, of course, requires removing the fuse for each circuit, then measuring the standby current using one of the methods shown previously. Note that not all circuits will show standby current. While determining the standby load is fairly easy, determining which loads have standby current may not be so easy. At some point, you may have to simply disconnect the device you suspect. One tool that may make this task easier is to use a mini clamp ammeter such as this BK Precision 316. You just put it around the lead and you can see we're measuring about 160 milliamperes, which we're actually drawing about 199 milliamperes. So these are not 100% accurate, but at least get you in the ballpark. And you can actually put it on either the ground side or the positive side. Now you may be tempted to use a meter such as this. This is a more traditional clamp meter, and this does do AC and DC, but the problem is it doesn't have the resolution that's required. This usually can't measure anything less than an amp, where this can measure down to 1 milliamp. These are a little expensive. These are around $200, so they're not going to be for everybody. When using a clamp meter, go to each device you suspect and measure it at its negative or positive lead before it splices into the circuit. This ensures only that device is measured. Do not measure on the main circuit itself, as you are likely to measure more than one load simultaneously, which will provide false results. As well, do not measure both positive and negative wires together, as again you will obtain an incorrect reading. If you have loads attached to the battery, such as a leveling system or slide outs, you may wish to measure them as well. If you have a battery disconnect switch like the one shown here, then turn it off. Otherwise, you will need to subtract the total loads measured at the fuse panel from the load measured at the battery. The result will be the battery loads themselves. Now that we have identified all of these standby loads, how do we correct it? Well, you will not be able to remove all of these standby loads as they are often necessary for the correct operation of the RV. But you can minimize the number of standby loads by disconnecting or replacing non-essential devices. If you have a 12-volt powered USB charge port, replacing it with one having a switch enables you to turn off the standby power to the device when not needed. If you have one of the touch-style dimmer switches in your RV, consider replacing it with one having an on-off switch. As well, some devices such as this Winegard head unit for the over-the-air antenna has a push-button switch, and that's usually a good telltale something having a residual current. So I put a switch on there to completely turn it off. Fortunately, there are clues as to whether a device will have a standby current. You can use these clues when looking for these devices in your RV, as well as when you shop for new items. If the device is remote controlled, there is probably a standby circuit that keeps the remote receiver powered. Also, if the device is turned on or off with a momentary contact push button switch, there is likely a circuit in the device to detect the push button action. Again, I would budget a nominal 20 milliamperes for those devices having such behavior. Now, there's nothing that says you cannot use those devices. Just remember, though, that they will add to the standby current that exists in your RV. And you can always hardwire a switch into the front of the device so that you can turn it on or off manually without having to have any standby current when you don't need to use the item. For example, if you watched any of my other videos, you may know that I have a wireless RF remote control system for my dimmers. And I put an on-off switch in front of the RF section so that I could use the dimmers with or without the remotes. And when I'm boondocking, I'll just turn the remote section off as I don't really need it. It's more of a convenience, and it removes the standby current requirements for those devices. So in summary, the amount of corrective action you have to take depends on the loads you have and whether or not you boondock. If you don't boondock, you probably don't have to do anything. But if you do boondock, minimizing the standby loads can be helpful. Thanks for watching.